Am I audible now?
Yes,
Yes,
sir.
sir, you are.
Okay. So shall we start the session or shall we wait for 1 or 2 minutes to join people? Okay, we'll start at 2:05. Uh, so today is basically our revision session, and we are going to revise 2 weeks today, week 6 and 7. So I'll be mostly covering those concepts, not entire week 7, week 6 and week 7, only those concepts which are important, and there is a chance that the questions will be there in quiz from these concepts. Okay, so I will summarize some concepts today, and then we'll see some questions like 4 to 5 questions, and that will be it.
So 5 and 7, right?
Not 5 and 7. Okay, six. Okay, 7 and 8. 7 and 8. Six is a refresher week, right? 7 and 8. That means CLT and parameter estimation.
Okay, sir. So will you also be taking the mock questions if anyone has any
No,
doubt?
mock question, that session is there tomorrow. So,
Okay, sir.
all the mock questions and some other questions will be discussed tomorrow if any doubts are there. So today we are going through some concepts in week 7 and week 8, and we'll see like 4 to 5 questions related to these concepts. That's it. Those also are from some your assignments only. Will that be okay?
Yes, sir.
So it will be a quick section, and any questions regarding mock and that? So week 5, I think sir has covered, right? So I think anyway on Monday, Andrew sir has taken the session, and most of the concepts were covered on those in these questions, right? And I think few questions are there from week 5. Initial few questions are there. So how to find the support and everything, right? So we are going to discuss only 700 today.
So maybe you said you are taking 5 and 7 today, right?
No, 7 and 8. Sorry.
7 and okay, fine.
Yeah. Okay, I'm sharing my screen. So I have already written the concepts here. I'm going through those concepts. If anyone is having doubt these concepts, let me stop and ask that, right? Okay. Shall we start now?
Yes, sir.
Okay. So week 7 is related to central limit theorem. So how you reach there central limit theorem, and while going there, what are the major concepts were there? So first of all, we have a difference between sample mean and the distribution mean. Suppose there are random variables from x1 to xn. So these are basically samplings, right? Or we can say samples, not having any confusion. So there are samples x1 to xn which belongs to a IID distribution x. So that means all are identically distributed and independent random variables, right? So what is the mean of this distribution? So this is expectation of xi, right? Xi or expectation of x, because every xi is uh, having a distribution of x, correct? So the mean of this distribution is expectation of x, and sigma square, that is variance, is variance of x, right? So what is the mean of or what is the sample mean then? If these are the random variables having mean equals to expectation of x and sigma square equals to variance of x, then what is the sample mean? The sample mean is x bar, which is which is x1 plus x2 to xn divided by n, right? So what will be the mean for that sample mean? Or expected value of a sample mean is same as that of the original distribution, correct?
Yes.
You can
Yes.
easily prove also that, and you know from the since these are the identically distributed and independent random variables, so we can easily say that expected value of a sample mean is same as that of the distribution mean, that is mu, correct? Now what is the variance of a sample mean? So variance of a sample mean is, so here there is a change, it's variance of a distribution divided by n, where n is number of samples, right? And that
Yes,
also
sir.
you can prove easily. It's like
Yes, sir. Yes.
not
Yes.
that difficult. So yeah, so if you have a distribution given as x1 to xn which belongs to IIDX, and with having mean as mu and variance as sigma square, then the distribution then the sample mean of that distribution is mu, which is same as that of a distribution mean, and variance is sigma square by n, which is variance of a distribution divided by n. Correct. Now the another concept is from that weak is a weak law of large numbers. So uh, uh, if given x1 into xn IID x, then the probability that x bar minus mu, which is greater than some delta, so delta is some constant, is less than or equal to sigma square by n delta square. And as n increases, so as n goes to infinity, this probability goes to 0, since delta is very small, right? So this is the formula to find the okay, here you can find n also, here you can find delta also, depending on the question, right? So that what does that weak law of larger numbers says? With probability more than 1 minus sigma square divided by n delta square is sample mean lies between mu minus sigma and mu plus sigma, since this gives you the lower bound. Correct?
So here X bar means sample mean and
Yeah.
mu means distribution mean.
Yes. So x bar is sample mean and mu is distribution mean. So the difference between sample mean and, so what does this say is your sample mean is lying between distribution mean minus delta and distribution mean plus delta with probability more than 1 minus sigma square upon n delta square. Correct? So delta is that you can say that interval. So in that interval, right, between that mu, the mu is distribution mean. So how much your sample mean is, how confidently you can say that the sample mean lies between this interval around your distribution mean. Correct? You're getting my point?
Yes, sir.
So maybe pictorially you can say that if this is a distribution mean mu, and you can say some value delta, so here it is minus mu minus delta, right? If some if this is delta, then this is mu minus delta and this is mu plus delta. Correct? So the probability that your sample mean lies between this interval is greater than 1 minus sigma square upon n delta square. That is given by your weak law of large numbers. Understand?
Yes, sir.
Okay. So next is moment generating function. So moment generating function is defined by expectation of e to the power lambda x. But here the condition is your expectation of that distribution, it should be equal to 0. That is, it should be centralized, right? So how can and if your random variable is not centralized, then you can centralize by subtracting distribution mean from that sample, right? So we'll take some examples. Suppose you have given the Bernoulli distribution. Okay, so Bernoulli distribution is let's say it's with parameter half. So how can we write Bernoulli distribution? So it will take 0 and 1 with probability half and half, correct? And what is the mean here for this Bernoulli distribution? Bernoulli
Half.
1 by 2. So that is expectation of x is half, right? It is not 0. So to convert it to centralized Bernoulli, or how can we say that? How can we convert it to centralized Bernoulli?
0 minus half.
X minus expectation of X.
So your random variable is taking value 0 and 1, right? X is taking value 0 and 1. So 0 minus expectation of x is half. So what the centralized Bernoulli, I can write it as like this, right? So it will take values 0 minus half means
Minus
half, and 1 minus half means
half.
plus half. So your centralized Bernoulli half, now it is having probability same, right? Probability won't change, correct? Because we have just shifted by 1 by 2, but the probability does not change, correct? But what is the expectation then here?
0.
Right? We can easily prove that also, right? Minus half into half, because how can we find the expectation? X into probability of x, summation of x into probability of x. So x is taking minus half here, so minus half into half is minus 1 by 4 plus 1 by 2 into 1 by 2 is plus 1 by 4. So minus 1 by 4 plus 1 by 4 is equals to 0. So thus we have converted your Bernoulli half into centralized Bernoulli, right? So how can we convert it? We can just have to subtract the distribution mean from the random variable, and the probabilities won't change. Okay. Okay. So now what is
one question, sir.
yes?
Centralized Bernoulli, making the centralized value means the making the expectations 0. Is it
Correct. Yes.
right, Nazar?
Yes.
Okay. Okay.
Expectation
Thanks.
of that new random variable. So Bernoulli half is one random variable, and centralized Bernoulli is another random variable, right? Because it is taking two different values. So we are just converting into a new random variable which is having expectation equals to 0. Yes.
Our purpose is to make the expectation 0.
Yeah, because
so that we can make it 0, 1, right?
yeah, so that we can find the moment generating function for that particular
normal 0, 1.
Okay, because to find the moment generating function, the condition is you should have
normal 0, 1
expectation equals to 0.
Yeah.
Okay. So so given suppose, okay, how to find the moment generating function for sum of IID random variables? So there are suppose x1 to xn are IID samples which are which belongs to IID.
Mayur, sorry to interrupt. You just said in order to find moment, we need to have expectation as 0, correct? This is what I heard, right?
Yes, yes.
Yeah, okay. Thank you.
So this is the condition to find. So if you wanted to find the moment generating function of any random variable, the condition is your expectation of that random variable should equals to be 0. So if suppose your random variable is not having that moment, so the mean equals to 0, expectation of that random variable is not equal to 0, you can convert it into a centralized random variable, and then you can find the moment generating function for that. Okay.
Yes. Okay.
Okay. So suppose you have a distribution x1 to xn. So I'm talking about this now. So we have a distribution x1 to xn which belongs to IID x, and so some of this random variables is nothing but x1 plus x2 until xn, right? How can we find moment generating function for that s? So okay, this step is clear, or should I elaborate this step?
So please elaborate.
Okay. So what is your moment generating function for any random variable? So mx of lambda is nothing but expectation of e to the power lambda x, correct? Right, no?
Yes,
This
sir.
is your
Yes.
moment generating function. So now your random variable is this, right? S. So S is a random variable which is sum of all these IID random variables. So x1 plus x2 plus xn, this comprises of S, correct? So how we wanted to find the moment generating function for this S, S. So it is nothing but expectation of e to the power lambda S, correct?
Yes.
Like this. Now what is S? If I substitute S here, lambda, what is this?
x1, x2,
x2 until xn, right? So I can write it as like e to the power lambda x1 plus lambda x2 until lambda xn. But I can write this sum, you know the property of e to the power a plus b is what? E to the power a into e to the power b, correct?
Right.
Yes, sir.
So I can write e to the power lambda x1 plus lambda x2 plus lambda xn as e to the power lambda x1 into e to the power lambda x2 into e to the power lambda x3 until e to the power lambda xn, correct?
Yes, sir.
So that is written here. Okay. Yes. Clear?
Yes, sir.
Yes, sir. Yes, sir. Correct.
Okay. Okay. So okay, so the central limit theorem is, yeah, so central limit theorem says if
Sir,
your-
just before going to central limit theorem, just have a confusion between like moment generating function and how it is related to moments. Like moments like it expectation of x, expectation of x, first moment, second moment, and all those. So how they related?
So I think sir has given you that derivation, right? how to find the, so if you can expand it, right, e to the power lambda x. So expectation of e to the power lambda x. So what is e to the power lambda x? You know that series, exponential series,
Yes, yes, sir.
right? So
Yes,
what
sir.
is e to the power x? It is 1 1 plus
1 by
1 plus x upon
plus
factorial plus x square upon 2 factorial plus x cube upon 3 factorial, like that, right?
yes, sir.
Correct. So if it is e to the power lambda x, then how can I write that exponential series?
Sir, excuse me, sir. Could you write that and explain, because I also had a problem in that.
Okay. I'll write it here. So what we are finding, this is our moment generating function, right? E to the power lambda x for a x, a random variable x. But I know that e to the power x. So if it is e to the power x, then how can I write this exponential series? It is 1
1
plus,
plus lambda x, 1 plus x.
right?
By 2 factorial.
Right, like
Yes,
that.
sir.
So if I wanted to write similarly e to the power lambda x here, how can I write?
1 plus all
Expectation will be
lambda x
outside,
by
no?
1
Expectation
factor.
will be outside first of all.
Yes, sir.
Then here with 1
Replace the lambda x with,
x.
I mean x
Yeah,
with
yeah.
lambda x.
Correct, correct. So it will be
Whole
lambda
square
square by,
by factorial.
Factorial
Yeah.
2. Lambda x cube upon factorial cube.
right, like that. Correct?
Right, sir.
Yes.
Right. Now if I'll expand this, if I wanted to take expectation within that bracket, so expectation of 1. So expectation of constant is the constant.
Yes, sir. 1
1.
itself.
Expectation of lambda x is
We can take lambda
Lambda into
lambda
expectation
expectation
of
of
x.
x.
what is here? It will be lambda
It's
square
lambda square
by
expectation
2
of x.
factorial
Yeah,
by
yeah.
2 factorial
Expectation of x square.
so x square, right?
Yes, sir.
Like that. Okay. So this will be the step. Now if I wanted to find the okay, how can I say this?
Some like questions are asked like find the fourth moment.
So fourth moment means whatever the, so what is the first moment is? First moment means expectation of x.
Simply expectation of x.
Is the first moment. Expectation of x square is second moment.
Second. Yes.
So what I'm saying is the coefficient of, so yeah, so expectation of x is your first moment, expectation of x square is your second moment, like that. So if you find for any distribution, and if you can convert that into this kind of thing, right? Suppose some distribution is like that. Suppose lambda into expectation of x, okay, plus say 3 lambda square upon 2 factorial into expectation of x square, like that. So you can compare with this expectation of e to
Okay,
the
so
power lambda.
3 would be the second moment.
3 would be your
Second moment.
yeah, 3 would be your second moment.
Okay.
Correct. Yes.
3
Right.
would be or 3 lambda square upon factorial 2.
No, lambda. So if you have to compare with this, right?
Yeah. Coefficient should be the moment. No?
So yeah, so 3 is the coefficient, na? Because this is same.
Yeah. Okay.
This component is same, only
Yeah,
3
yeah.
is outside. So
Yeah,
generally
yeah.
it will be like sigma square or something, whatever term is there. So you can just directly consider it as a second moment or third moment. Like
Yes, sir, yes.
okay. Okay. So shall we go to central limit theorem now?
Yes.
Yes, sir.
Yes, sir.
At the end, we'll see some problems also. So 3-4 problems. Okay. So central limit theorem says that okay, you know this, right? Y minus n mu divided by root of n into sigma, where it goes to so it is approximately n01. So what is y here? First of all,
Sum of IIT random variables.
divided by root n. Divided by root n.
Divided by root n, yes.
Correct, na? So if, okay, I haven't written here, so I'll write it here. So suppose x1 to xn are IID x, okay, and y is, if I can I can write y as sum of all this xn divided by root n, okay. If this is my y, then I can say this y minus n mu divided by root n into sigma is approximately equal so okay, so this distribution is approximated to normal 0 1 distribution, right? And we know we can easily find out the values of fz, which are nothing but the CDF of normal 0 1 values, right? So what is n here? The number of samples, correct? What is mu?
Excuse me, sir.
Ah.
Sir, one question here. Even if we do not divide y by root n, if it's just the summation, then also I think it would be root n sigma. Because if we apply the normal, that z, the way we find out the z square, so that is x minus the expectation divided by sigma. So if y is just the summation of all those IIDs, then mu would be what? N into the mu.
Yeah. Sorry.
And variance would be what? Standard deviation would be what? Root n into sigma.
So you can convert it into the same thing, no? Whatever your
So
distribution
isn't this becoming a little bit complicated, like dividing it by root n for no reason?
It's not. No.
Actually, like that is the definition of like CLT, like
CLT.
that approaches to that normal 0 1.
So this actually this approximated to this to the power
She's saying something else.
minus lambda square sigma square by 2. So moment density function for this, right? For this.
Yeah, that y is not whatever it is written. That y doesn't require that divided by root n.
Okay,
so
okay.
in that expression, sir, the below expression.
That is just actually becoming a little bit confusing, because we could just have the summation, and if we compare it with the normal z, then the same thing we are going to get.
Yeah, correct.
Sir,
Sir, that was for moment and rating function. Actually, how it will convert to that?
See, here normal, in the normal distribution, 0 and 1 is the sigma square, right? And if you just add them up, then you will get root n sigma as your SD, right?
No, sorry, I didn't understand. So 0 is mu, right? And this
1 is sigma square. Yeah. So if I just x1, x2,
but not this mu, right? This is not this mu. This is distribution.
Sir, I'm not. I can't see first.
Yeah, this no. This is distribution mean.
Yeah.
So this is the distribution mean of this.
Yeah, basically
we are converting it to the normal 0 1, isn't it, sir? We are converting it to normal 0 1.
So yeah,
yes.
That is,
so after doing this, right? Suppose your y is some random variable. Okay, so your y is some random variable. We are converting by doing these operations. You are converting this y
correct to normal 0 and 1.
Yes. Yeah. So this mu is distribution mean, and this sigma is distribution standard deviation. Okay, no?
Yeah, basically that formula, the y minus
yes, sir, the root n, it was actually derived from.
Okay, see, this is a definition of the formula. So
if what we'll do is, don't divide it by root n sigma, then you will get n 0 root n sigma.
What will get? 10.
If I don't divide it by root n sigma, then and just do x1 plus x2, that is my like x sum of x IIDs, then I'll get, if I do y minus n mu, if I set it up like this, then I'll get n 0 comma root n sigma as my distribution.
Yeah, but that is not of any use, no?
Exactly. That is why if I'm dividing it by root n sigma, then I'm
correct. Yeah. So we are transforming into this.
So I'm just scaling the variables height wise.
Yeah. That is the only thing we are using here. So that's scaling.
I didn't understand.
So what he is saying is, he's just saying.
So maybe you can take an example and then demonstrate how this converts to.
Linear algebra will work. You don't have to do it. Right? What is x1 plus x2? If this is the random variable, then what is your standard deviation? You can find it.
Okay. Maybe we can see. Suppose let's say we have a random variable y. Suppose or x1 to xn. Suppose it is. Okay, it's maybe I can show it
Don't
here
scale
only.
it. Just make
Yeah,
it 0 mu. Then you will get take any distribution and make it 0 mu.
Yeah. So suppose y is some distribution. Okay, with the mean equals to some mean is there with mean mu and standard deviation. Variance is sigma square. Okay. If I wanted to convert into normal 0 1, then how can we convert?
Y minus mu
So it will be
upon sigma.
and suppose there are n samples of this.
Yeah, then we have to y minus n mu upon under root n sigma.
So what is this distribution? Y minus n mu. If n samples are there, this is
In 0 comma sigma square.
sigma, right? And if
Yes, sir.
if I do this, then this distribution become
N01.
So that was what I was talking about. We could actually take the sum instead of like dividing it by root n. But I believe somebody mentioned why we were taking root n.
Yeah, even if you take the sum, this is going to happen. Even if you take the sum of it,
however you can
have to
do
divide it by root n.
Okay, maybe what we can do is after
Y is actually sum of x.
Yeah.
Sum of I. Right?
So what we can do is at the end we'll see 2-3 problems regarding the CLT. There you can easily find it out, right? We can see how we can mapping it to this normal 0 1 thing. Correct?
Actually, confusion arises in the last chapter 8.
Actually, there is no confusion actually here.
No, not here.
I don't understand.
Confusion arises at the case when we estimate the mu hat minus mu upon sigma divided by under root n. There they take mu hat minus mu divided by sigma upon root n for the confidence interval finding.
Okay.
This confusion arises there because here we do y minus n mu upon under root n into sigma, and there they are using mu hat minus mu divided by sigma divided by under root n, because that is not the sum. But this confusion, I think, makes calculation mistakes where to use y minus n mu and where to use mu hat minus mu.
So that mu hat is a parameter estimation, right?
Yeah.
Estimated parameter is there. So that is different thing, na? And one more thing is the confidence interval is not there in your syllabus for this.
Okay, but the question is there, sir.
No, you can skip that thing.
Okay.
Sir, I have only one question. Can I ask now? So
yes.
this CLT is derived from the standardizing normal distribution, right? X bar minus mu divided by sigma. From that also we can derive this, right?
Yes, you can do that.
Yeah, fine. Thank you.
So okay, leave about this expression.
Okay, sir. If confidence interval is not there, then no problem at all.
Yeah, confidence interval is not there.
Then there is no problem. This is okay, fine.
You can
because
just
we are using.
You can just follow this distribution. It will be like approximately.
Yeah. This is okay, sir.
Normal 0 1. You can find that FZ for that, right? Okay. So yeah, don't make like lot of things at a time so that it will get confusion.
Yeah. Okay, fine.
Okay. So this week 8. So week 8 is regarding the parameter estimation. So
sir, alongside we don't focus on the concentration phenomena also, right?
Yeah, because see why I'm not taking all this stuff is because those are not there in the quiz.
Yeah, that is where I'm coming from. It's not there, so we will not focus on that.
Yeah,
right?
so no need, because anyway you are going to prepare for exam, right? If you want to study it, you can study it. So there is no problem in studying it. But here it's not needed. So most of the people like now they wanted for like to solve the questions how and which topics are there for quizzes.
Yeah.
You can focus on that. That will be better, right?
Yeah. No, mind test is also the same.
Yes. So
only from quiz perspective.
Concentration phenomena and everything that will add up a lot of content. and
Yeah.
anyway, it will get very like sometimes it will get confusing also, and moreover it is lot of content is there, and we are not going to ask any questions from that concentration phenomena, so there is no need to study here, right?
Fine, sir. Thank you.
Yeah.
Yes, sir. Yes, sir. Fine.
So VCAT is related to our parameter estimation. So before entering into how to estimate the parameters, so there are certain terms which are important. So which is bias of an estimator. So bias of an estimator is suppose x1 to xn are the samples which are distributed according to the IID x, okay, with parameter theta, which is unknown parameter. So what is the estimator for the theta? So it is function of those x1 to xn or theta dash, right? So it is a function of x1 to xn. What is bias of theta dash and theta? So theta dash here is its estimated parameter and theta is your original parameter. So bias between your estimated parameter and theta is nothing but expectation of theta minus theta dash minus or theta hat minus theta. Okay, and theta hat minus theta is nothing but an error, right? Because your original parameter was theta, you have calculated the or you have estimated a parameter theta hat here. So the difference between theta hat and your original parameter is nothing but an error. So expectation of that error is a bias. Okay, right? Hello.
Yes, sir.
Yes, sir. Fine, sir. Fine.
Tell me yes so that we can move forward.
No, fine, sir.
Variance is the usual definition of variance. So variance of any random variable x is, how can we find it out? So it is nothing but suppose variance of x. So what is variance of x?
Expectation of x square
Expectation
minus
of x minus x bar square, right?
yeah, or else we can use that also, expectation of x square minus expectation of
That
x whole
also you
square.
can, yeah, x square minus
Expectation of x whole square.
Yeah, that is also useful. So yeah, mostly this expression is very useful because generally we can find expectation of x. So some of the examples we are going to find expectation of x, we know variance of x, and we can find out expectation of x square.
This is the first moment, this is the second moment, right?
Yes, correct. So to find the second moment, this expression is very useful. But yeah, leave it. So this for parameter estimation, variance of theta hat is nothing but expectation of theta hat minus expectation of theta hat to the whole square. Okay, so this is the simple definition of an estimator. Okay. So there are two approaches of estimator design. So one is method of moments, and another one is maximum likelihood. So what is method of moments? So given that x is a distribution belonging to some fx of x, so this is a probability distribution with parameters theta 1, theta 2, theta 2. So suppose x is a Bernoulli distribution. X belongs to a Bernoulli distribution. So how can we write? X belongs to fx of what is fx of x here for Bernoulli?
Bernoulli.
So actually, yeah. So this is the fx of x means probability distribution. So what will be the probability distribution for Bernoulli? For random, so Bernoulli random variable. So it will be 0. So so it will be, sorry, it will be 1 minus p for 0 and p for 1, right?
P for 1 and 1 minus P for 0.
How can I write Bernoulli distribution? Bernoulli distribution 0, 1, right? And what is the probability for 0?
1 minus p.
1 minus P and P.
Like this we can write, right?
Yes, sir.
Okay. What is the distribution for, suppose I wanted for any continuous random variable, for example, exponential.
This is PDF, no, sir. PX.
This is PDF. Yeah.
PDF.
So exponential for exponential distribution with parameter lambda, what is the distribution for this? So my x is suppose exponential lambda. Then what is the PDF for that?
lambda e raised to
lambda
power minus lambda x or
1 by lambda.
No.
Yeah, it is
This
fine.
this PDF
Function is this y lambda and e to the power minus lambda x.
So if you are going, so suppose your distribution x is belonging to some fx of x. So if I can write x is belonging to exponential of lambda, right? Then that means the probability distribution for that x is this, right? Lambda e to the power minus lambda x. Correct? No?
Yes, sir.
yes sir.
And to how can you find the sample of moments? So sample of moments is nothing but 1 upon n. So it is just a sample mean, right? So okay, the first mean is the sample mean. Okay, I'll write it. Maybe we can find the
First expectations,
we'll find the method of the sample moment for this exponential distribution.
I have just one question.
Yeah, yes sir.
I tried to clarify with Andrew sir also, but I did not get the chance properly. Okay. So this lambda e raised to power minus lambda x, for example, when we are drawing a curve, right? Lambda e raised to power minus lambda x is the line, correct? That is the form of this expression. Is the understanding right?
Why it will be line? So
no, not the line. I mean the curve. Whatever. For example, we are drawing we are drawing that curve, right?
Yeah. So
whatever would be the value of lambda and x accordingly, that curve will shape out, and that is what is the interpretation of this thing.
Yes,
correct.
Yes, correct. Yeah.
Right.
Yeah. So this is just this is actually the that curve will be there. That what is it?
So we are giving the that shape of the curve in this particular form.
Yeah,
correct,
yeah.
Right?
The shape. Yeah. The word I forgot. So generally exponential distributions, right? So
yeah.
What is e to the power x? It will be positive, right? Like this.
Yes, right.
Yeah. And what is negative e to? This is e to the power minus.
Right.
So we are we are going to say like this, right? So the function of this curve is e to the power x, and the function of this curve is e to the power minus x, right? Similarly, for this also we can draw the curve.
Right.
It will mostly be like this only, but this lambda is some constant. So if you multiply that accordingly, that will change. But
so this becomes the curve. And
only.
then when we are taking the probability, then we take the integration of this particular curve between some limits, and that is what comes out to the probability, right? Just wanted to reconfirm my understanding.
Yes.
Okay,
So generally for continuous distributions, we are not able to find the probabilities at a particular point, right?
Yes, right.
Zero.
That is becomes at zero. Right?
So for that, what we are going to do, we are going to find probabilities from CDF. That's why CDF is introduced there, right?
Right.
For PMFs, it is very easy. PMF we can find at any point of time because it is a discrete distribution. But for continuous, we have to find by using CDFs. Okay. So these are actually nothing but the shapes. This whatever, suppose normal also, it is 1 upon root 2 pi sigma into that thing there. So that is a expression for the shape only, the Bell curve shape, right? So correct. So how can I write? So mk of this x1 to xn is nothing but 1 upon n summation of I equals to 1 to n xi to the power k. So tell me what is first moment. So if I say m1 of x1 to xn, so this is my first moment, right? Instead of k, I'm writing 1. So what will be the expression for it? So it will be x1 plus x. So xi to the power k. So xi to the power 1. So okay, I'll write it. One more step I'll write. Summation goes from 1 to n xi to the power 1, right? So I can write it 1 upon n. So what is this? x1 plus x2, right? Until xn. So this is sample mean. So this is my first moment. Correct?
Yes.
What will be my second moment?
Second.
So it will
x1 plus x2 plus xn whole square.
No.
x1 square plus x2
no, x1 square. Right.
No.
Yeah. x1 square plus
x2 square plus dot xn square. So similarly, we can find for any finite number of, right? So I can write for m4. How can it be m4? Fourth moment. So it will be 1 upon
by n 4 plus
1 upon n into x1 to the power 4 plus x2 to the power 4, like that. Okay, fine. No.
So Mayur, the x4 thing, in the lecture, it has been generalized to 3 sigma 4. Is that the generalization, or is it specific case?
Not, I think it is not general. I think that is the
that is for normal. It is for normal.
Yeah, for normal only, right? That I think that is shown in the 7th lecture. So 7th lecture.
7th, yeah. So that's not the generalization.
No, not generalized. No.
So if we have a normal with mean 0, right? If we have a normal, of course, I mean saying I'm normal with mean 0 and some sigma is given. Then in that case, we can simply take 3 sigma square and come to conclusion, right? That this is the 4th moment.
Correct.
Then at least we can use, right?
Yes.
Yeah.
Correct. For that only, I think sir has shown that, na? So that is moment generating function we are finding out. So
but in the questions it comes as find the 6th moment. So then there was no use of 3 sigma 4.
Yeah. So you have to find then again. So you have to go 2-3 steps further.
Just trying to interpret what is given and what is being asked. So that's where I was coming from.
Correct.
Okay, thank you.
Okay.
Thank you again.
So can we solve one question here regarding this method of moments? Suppose my distribution is, so we'll quickly solve one question. So this is actually sir also has shown in the question. What do you say? What's question in the lectures? So I'm taking the same thing. So my x1 to xn is belonging to IID exponential. Okay. With parameter lambda, and I wanted to find the estimator for lambda by using the method of moments. So how can I find it? So here lambda is, you know what is so my first moment is what? Expectation of x, right? That is mean.
1 upon lambda.
Correct. So what is the mean for exponential distribution?
1 by lambda.
So I can write expectation of this x is 1 upon lambda, and to which I have to equate it with my first moment. First moment, right? So I know what is first moment. So it is nothing but 1 upon n x1 plus x2 until xn, right? That means it is a sample mean, right? So my samples are x1 to xn, which belongs to IID exponential. This is my exponential. This is my sample mean, and which is nothing but my first moment. I am going to equate with 1 upon lambda, and so I don't know what is lambda here. So the estimator for this is nothing but what? N divided by x1 plus xn, right? Okay, this you understand? Is how I'm going to find the parameter estimator. Now from the exam point of view, suppose there are 5 samples. I'm just taking some random numbers, okay? Suppose 2, 3, 4, 7, 9. These are my IID samples according to exponential lambda. Okay, I wanted to find the estimator by using these samples for by using method of moments for lambda. So what will be my lambda hat? That is my question for this distribution. So what should I write for this? What should be the answer for this lambda hat?
5 by 2 plus 3 plus 4 plus
1 by
7 plus
inverse of the average.
So inverse of the average. So what is the total number? So n divided by x1 is
25.
correct.
25
plus 4 plus 7 plus 9, right? Correct. So that is
directly use this formula.
So yeah, I have used this formula, right?
Okay.
We have already. So what we have done, we have found this formula by using this method of moments, because method of moments, the first moment is my expectation of x, right? So it is nothing but expectation of x. So here x is belonging to IID exponential lambda, and I know what is the expectation for exponential distribution? It is 1 upon lambda, correct? And my method of moment, by using method of moments, my first moment will be 1 upon n x1 plus x2 to xn, and if I rearrange these terms, I will get lambda hat equals to n divided by x1 plus x2 until xn. Okay, can we solve one more problem? So
Yes, sir.
So,
Yes,
so
sir.
it will get clear. So okay,
Yes, sir.
tell me. Okay, I'm saying you. Suppose I will take which one? Let's say Poisson distribution will take. So suppose
Take one with two parameters or more than one parameter problem.
that will be only for, I think, two distributions.
Normal.
One is for normal, and I think it's binomial also.
Gamma.
Gamma distribution. Okay. So for which you wanted to take? Tell me. For gamma, should we take?
Gamma, sir.
Gamma?
Yes, sir, gamma.
Okay. Let's say we are going to see for gamma. So suppose I'm taking some random numbers here. Suppose these are my sample means, or these are my IID samples for gamma distribution 2, 3. Gamma distribution, how it will be? Okay, we'll see whatever the answer will be. Suppose I'm taking 3, 5, 8, 9 like this. Okay, this belongs to gamma, alpha, beta, and we don't know both of them, right? We don't know both of the parameters. So what is the expectation for gamma distribution?
10 plus 70.
No,
Alpha by beta.
Alpha by beta.
Alpha by beta.
Correct, no? And what is the expectation of x square? So I don't know what is the variance, but okay, what
Alpha
is
square by
the,
beta square.
first of
plus
all, what
alpha by
is
beta.
variance of x? First of all, okay.
Alpha square by beta square plus alpha by beta square.
Beta square.
No, alpha by beta square, no.
Yes, sir.
Variance of gamma distribution is alpha by
Alpha
beta.
by
Variance,
beta.
yeah. Variance is this, yes.
Yeah. So according to our method of movements, we are going to equate the first moment with our expectation. So this I am going to equate with M1, and this I am going to equate with M2, right?
A small m1, no, sir?
So, okay, not M2. So M2 will be equating to
Expectation of x
square.
square.
Okay.
From here we can find it.
We can find the expectation of x square. So how can we find? So we know what is variance of x is
Expectation of x square
minus.
Sir,
minus.
here we will equate this expectation of x to a small m1, no? Then we will replace there by m1.
No. See, yeah, here we are going to replace, so equate M1 with expectation of x.
Directly we can equate with capital M1.
Yes, that we can do. But I'm talking about the second moment.
Okay.
So second moment will be expectation of x square, right? What is second moment? I told you, no. This is the equation.
Expectation of x square.
Mk is nothing but this.
Yeah.
Xi to the power k. So what is M2? It will be 1 upon n summation of I equals to 1 to n xi square.
X square.
So this is nothing but actually expectation of x square, right? Because divided by n, and in the numerator it is x1 square plus x2 square, like that, right? So what I wanted, so I'm going to equate this with expectation of x square. Now I have the value for variance of x. I have so what I know is, I know here expectation of x for the gamma distribution and variance of x for gamma distribution, but I don't know expectation of x square. So by using this equation, which is everybody knows, so variance of x is equals to expectation of x square minus expectation of x to the whole square. So by rearranging these terms, what we can get? So if I wanted expectation, I wanted this, right? So this term will go to your left side. I'll write it as variance of x plus expectation of x to the whole square. So what is variance of x for gamma distribution? It is alpha by beta square. And what is expectation of x? It is alpha by beta. Right? And to the square. So whole square will be
alpha square by beta square.
Alpha square by beta square. Okay. Okay. So can we find M1 from given samples?
Yes, sir.
So what will be the M1? So for this
M1 will be 5.4.
So it will be 2 plus 3 plus 5 plus 8 plus 9 by 5. So I don't know whatever the value is.
27 by 5.
27 by 5.
Okay.
5.4.
5.4.
Okay, 5.4. What is M2?
4 plus 9 plus 25 plus 64 plus 72 by 5.
Yeah, so it will be just squares of these terms divided by 5. So can you calculate, someone? So it will be 4 plus 9 is 13.
34.8.
34.8. Okay. Sorry. Okay, it will be 34.8. Okay. Now, what we have decided, we are going to equate this M1 with expectation of X. So the equation will become what? Alpha by beta equals to
5.4.
M1. M1 is nothing but 5.4, right? Or fine. Okay, I think we can find it out in terms of M1 and M2, right? Okay,
Yes,
anyway.
sir. That will be.
Yeah, anyway, we can find it out from here also. So it is 5.4. So one equation I will get is alpha equals to 5.4 beta. This is my first equation. Then M2 will be equated with this expectation of X square, correct?
Yes,
so
sir.
Here it will be alpha by beta square plus alpha square by beta square equals to 34.8. Now I know alpha is what? 5.4 beta from equation 1. I can replace alpha by 5.4 beta. So it will be 5.4. So 5.4 beta divided by beta square. So that's beta and this will get cancelled, right? Here. Plus 5.5 square, 5.4 square, done, equals to 34.8. So if you solve this equation, you'll get value of beta here, and that beta value you can again replace in this equation 1, you will get alpha. Okay. Okay, anyone who does not understand these steps, just let me know so that I can. Okay, we have space here, right? So maybe I'll write it again here. So yeah, you can actually find this in terms of M1 and M2, and then you can directly replace these values. But if you don't want, you can do like this also. So this
Yes,
was
sir,
my
this
equation
was
1. So alpha was 5.4 beta divided by beta square. Alpha I can replace from equation 1 as 5.4. So it will become 5.4 square into beta square divided by beta square, which is equals to 34.8. So this beta square will get cancelled. This beta and this beta will get cancelled. So it will become what? 5.4 divided by beta equals to 34.8 minus 5.4 square, correct? So can anybody solve this? 34.8 minus 5.4 square?
5.64.
So 5.4 divided by beta is equals to
5.64.
So we get value of beta as 5.4 divided by 5.64. So it will be
0.96.
96. So this is the value of beta here. I can replace this value by beta here in equation 1. So from here, alpha equals to 5.4 times 0.96, right? So you can find the value of alpha also. Okay? Fine. This is method of moments. So
Yes,
it's
sir.
not
Thank
that
you.
difficult, right? Okay.
Yes, sir. Fine.
Okay. So we'll move to our another parameter estimation method, which is what?
Maximum likelihood.
Maximum. I can write ML, right? ML estimator. So in ML estimator, there are 3 steps, right? First of all, suppose x1. Okay, I will write the basic things. So x1 to xn belonging to IID x. This is our usual method, right? Here theta with parameters. So x is having parameters theta 1, theta 2 until whatever. Okay. Then the fx of x is, it depends, because fx of x is what? Your probability distribution, and it depends on what?
Theta 1,
Theta 1, theta 2, and like it depends on your parameters. So I wanted to find the maximum likelihood for this fx of x. So first step is to find likelihood function. So what is likelihood function for x1 to xn? So this is the notation for that, L of x1 to xn. So this is the product from 1 to n of all the this PDFs. So what is this mean by? This is the PDF of, so I'm not saying about only PDF, I'm saying the probability distribution. I'll say, because PMF, for PMF also you can find it out. So this is probability distribution for x, with x is having parameters what, theta 1, theta 2 to theta n, right? What we are going to do, we are going to have a product of this. So this pi means what? Product. So product of this all the PDFs or PMFs for the given distribution, and for n number of times we are going to multiply them, right? That will give you the likelihood function. The next step is to find log likelihood of this function. So what is log likelihood? It is nothing but the log of L, or log of L of x1 to xn. So okay, whatever expression you will get, you have to take the log of that function. Right. And the third step is
differentiate.
Yeah, to differentiate with respect to what? The parameters. So suppose you wanted to find only for theta 1. Okay, in the previous example, what we have gamma equals to alpha beta, right? So if I wanted to find for alpha, then my beta will be constant, and I'm going to differentiate with respect to what? Alpha. Right. Okay. So I'm going to differentiate this log likelihood function. So this is nothing but d by d theta. So theta might be anything. So for whatever theta you are going to form, you're going to take the differentiation of that. So there is you can write it as like argmax of theta 1, theta 2 of the product of this thing. That is your final ML estimator. But I'm not going to write that expression here. So what we will do is, better we'll take one example and we'll try to solve that example. Okay.
Can you solve that x1, x2 geometric P, this ML estimator, because I have a doubt how to write the ML for geometric.
Okay. So geometric, yes. So we'll take the geometric P, no? So suppose x1 to xn.
IID, yeah, xn, yeah.
IID geometric P. Okay. So suppose x1 to xn is IID geometric P. Now, what is my likelihood function? Okay, first of all, tell me what is the fx of x for geometric function?
It's 1 minus p. That's where I got it in the. Yeah.
Right.
Minus p.
So here for x, if it is there, so x means what? For x number of tosses, right? So I can write actually
that n as x.
X, right? N as x.
Yes, sir.
This is fine, right? So this is what? For x number of tosses, what is the probability for my given geometric distribution? So it will be n minus, x minus 1 success, failures. So I'm getting the first success after x minus 1 failures. That is my geometric distribution. So I can write it as 1 minus p to the power x minus 1 p. Okay. Now, what is likelihood function for this? So what I said is, it is a product of
n such
right, which is xi, correct? No, xi. So I can write it as for x1, what it will be?
P xi minus 1. Right?
x1 minus 1.
x1 minus 1 to the power.
I need not to write like entire things and add, like multiply this. I can write in terms of product itself, right? I can write fx of, so fx of xi is what? 1 minus p to the power xi minus 1 into p.
Into p.
This is okay?
Yes, sir.
Yes.
This is okay?
Yes, sir.
This is my likelihood function for geometric distribution. So next step is what? So okay, first of all, find the product of this. So what will be the product of this?
P to the power n.
1 minus
1
p.
minus p to the power summation of I equals to 1 to n xi minus xi, right?
Yes, sir. Minus n.
Minus n into what? P to the power?
P power
n. This is okay? Everybody understood this step?
Yeah.
Yeah.
Okay, na? Okay. So this is what my likelihood function. So what is my log likelihood function of this? So I'm just going to take log of this value. So it will be if I take the log of this first term, what it will be? So the numerator the power will come before. So it will become summation of I equals to 1 to n of xi minus n
minus the whole thing multiplied by log of
1 minus
n
p.
Plus
This fine, no? Everybody.
yes, sir.
Yes, sir.
Plus n log p.
N
log p.
This is my what? So I can actually do like this also. So I'll expand this little bit. So it will become summation of I equals to 1 to n of xi.
We can drop some constants, no, sir, here.
So yeah, that's what I'm trying to.
Okay.
Okay. This fine?
Yes, sir.
Now, the next step is because since we are finding for what value, so we are finding the estimator for what?
P.
So what should be my next step? It should be differentiating this log likelihood function by with respect to what?
P.
With respect to p. So I'll write log L as h. Okay. So what I'm going to do? dh by dp. So dh by dp, and I'm going to equate it 0 later in the next step. So now what I have to do is I have to find the differentiation with respect to p. So what is the differentiation for this term? First term?
Sigma.
So what is log of differentiation of log of x?
1 by x.
1 by x. So what is the differentiation of log of 1 minus p?
1 by 1 minus
p
into minus
1.
Minus 1.
Right?
Yes, sir.
Yeah.
And summation of I equals to 1 to n xi. That will be there.
Yes, sir.
Then what is this?
N
plus
n by 1 minus p
plus 1 by 1 minus p.
So better I can write like this, right?
Yes. Yes, sir. Yes. It's the same thing.
Same thing, no?
Yes.
What I'm doing is I'm just taking this term as it is, and I'm just differentiating log of 1 minus p. So instead of doing this this step, the intermediate step, this is better, right?
You can erase the intermediate.
Yeah, you can erase, or you can if you wanted to do in that way also, that is fine. It's just one more step. So yeah, so
n
here
by p.
It is n by p, and what I'm going to do, equate it with equals to 0. This is okay?
Yes, sir. Yes, sir.
Okay. Now, this term will go to that side, so it will become n upon p equals to 1 upon 1 minus p summation of 1 to psi, right? Oh, sorry.
N
xi minus n. So
yes,
it will become what? 1 minus p. Okay, this term I'm going to, like, this term will go to the numerator towards left side, so it will become 1 minus p upon p. That n will come down here. So this step will be fine. Directly I'm writing it 1 upon n xi divided by n minus 1.
Yes, sir.
Is clear?
Yes, sir.
So what can I write, like 1 minus p upon p? I can write it as
1 by p plus minus 1.
Correct, no?
Yes, sir.
And this minus 1 will get cancelled.
Cancelled.
So this will remain with.
It will be inverse of.
just a minute, I will just write it into the next page. Yeah. So it will be 1 upon p equals to what? Summation of I equals to 1 to n xi divided by n.
Divided by n.
So, but I wanted for p. So inverse of it is p hat equals to n upon
N by
summation of I equals to 1 to n xi. So here it is n upon
x1 plus
x1 plus x2 to
x2 plus till xn.
So this is my estimator for
average.
geometry.
Inverse moment, first moment, inverse of
Yes.
first moment.
Yeah. Correct?
Yes, sir.
Thank you. Actually, in the solution, it was given in a different way. 1 minus p power xi. So that's where I got confused. It is actually xi minus 1, right? That PDF when you're
So
writing.
maybe that is given for xi plus 1. Maybe.
No, it was x1. It is an activity question, 8.71. That's where I got confused. That's it. Thank you. Yeah.
Okay. Okay.
But the solution given by the course team was different. 1 minus p power xi alone she has given. That's why. Yeah. Thank you.
Okay. I'll check what. Which one you said?
Yeah. 8.7.
I don't think that
one question
that will be wrong. But okay, I'll check. I don't know. So, okay, but this is the solution for like how to derive the estimator for this. So suppose, so this is the estimator for my geometric distribution. So suppose there are samples. So 3, 5, 3, 5, 2, 2, 1. Huh? Or 3, 5, 2, 2. Suppose 3. 3. So these are my samples according to IID geometric P. Now find the estimator for these samples. So what will be the estimator for
5 by
3 plus
15. 1 by 3.
So 5 by how much?
15.
Yeah.
We can directly use this formula also, no, sir?
Yeah, that's why we have found out, no?
Yeah.
So whenever you if you remember the formula, you can use directly. If you don't remember, what you have to do is you have to first derive and then you can use it for the given samples. So basically we have to follow these 3 steps. That is it. Okay, na?
Yes.
That is about our ML estimator. So yeah, that is only comprises in week 7 and 8, which is very important. Apart from that, the confidence interval is not there. We are not going to say about any consistency and okay, those part we are not going to have. So maybe we can take 2-3 examples from our CLT portion, because a lot of people said so there are certain problem in that CLT. So maybe you can suggest me problems from CLT.
Okay. Convergence is also not coming, sir.
Sorry, yeah. Tell me what?
This convergence is also not coming in the examination, no?
Which one?
Convergence.
Yeah, nothing. Yeah.
Mean square error, this will not come, right?
Yeah.
Okay. Thanks. Because it is in the chapter 8, not there.
Sir, what percentage of the questions will be from 5, 7, and 8? Like,
so mostly your paper will be having from 5, 7, and 8. So you can expect it within 70 to maybe 85% or something like that.
Okay.
So is mean square error is not coming in exam?
No.
Wow. Thank you, sir.
Thank you very much.
That is under week 8, right? Mean square error.
Yeah, week 8, last part.
So mean square error is a risk, no?
Risk, sir, risk.
Comes under week 8, right?
Yeah, week 8, yes.
So we have that also.
It is there.
Yeah,
but
risk is there.
We are not going to ask questions on the risk. So yeah, I'm saying it.
Only bias and variance.
That's why we are being happy, no? Because that part was so confusing.
Sorry. So,
sir, will 5 will be discussed?
Week 5, okay, maybe I can discuss, but there is like not a lot of concepts, right? It's like marginal distribution and okay, what part you want to discuss in week 5? Tell me that thing.
Topics to focus.
Sir, I want every part, sir.
What?
Yeah, like a quick recap.
Topics to focus mainly.
Yes,
What
sir.
are topics to focus for the quiz?
Okay. So shall we do that first? So that, but if I'll do, then I won't take more questions. Only I will take 1 or 2 questions. That will be fine.
7 is more, I think, important. Week 5 is
No. If week 5 is also important. It's not like week 5 is not important. So,
Hello, sir.
Hmm.
I have dot in practice assignment. Week 8, question number 4.
Okay. Today's actually discussion is on revision. So tomorrow we are having, but let's see. Okay, one question. I got 8 point.
Practice assignment 8, question number 4.
See, you have given the solutions for this also, right? Practice assignment.
Sir,
No?
but I
Okay,
I
don't
saw the
understand.
solutions, but I didn't get it now how to
Question
approach
number?
this.
Okay,
4. Question number 4.
Okay. So yeah. 4. Okay. Let x1, x2 to xn be IIDx and a1, a2 be such that summation of all ai equals to 1. Define the estimator for mean xi. Define the estimator for the variance. Okay. So okay, we can solve this. Okay, you tell me first.
Okay.
What is given there? Estimator for
estimators. It is given that
so estimator for mean. So first of all, estimator for mean is given. So
Yes,
x
sir.
bar is equals to summation of
AI xi
upon n, right? Is it like that?
AI xi
only AI xi. Okay, not percent.
Yeah. And the variance, I think.
For sample variance, it is
sigma AI into xi minus x bar ka whole square.
Okay. Okay. So first option is and
with
expectation of
variance.
x is given. Yeah, that is okay. That is fine. So first option is x bar is an unbiased estimator. So how can you find? First of all, you have to find the estimator for x bar, right? So this is the given estimator. So when we say that estimator is, so this is estimator, right? X bar is an estimator. So I can write it as like x hat also, right? So what is my bias? Bias for x hat and x is
expectations of x hat minus expected minus x bar. Yeah.
Sample mean actually, right? So
it is distribution mean na minus distribution.
Okay,
okay. It is mu, na sir.
Okay, so mu. So
mu.
Okay, that is okay. So okay, maybe I won't make any confusion in x hat also. So that was this is x bar. Now tell me how to find the expectation of this term.
This
So
is
expectation of this is
a1 x1 plus a2 x2.
So what we are going to find is a1 x1, right, plus a2 x2 until an xn. Correct, no? This expectation can be, since it is summation, so I can write it as like this also: expectation of a1 x1 plus expectation of a2 x2. Correct?
Yes, sir.
Okay, and again the next step, this is a1 a2 are the constants. So can I write it's like a outside into expectation of x1. What is a2 expectation of x2, like that. And what is so since x1 x2 and xn are IIDx.
Yes, sir.
So what is the expectation of x1 then?
Mu.
So it will be a mu, sorry, a1 mu plus a2 mu plus a3 mu until an mu. So mu can be taken out common. So inside it will be a1 plus a2 plus a3 plus an. And what is the additional information given? A1 to an, the sum of this is equals to
1.
1, right? See here.
Yes.
Let a1 to an is greater than or equal to 0 such that summation of I equals to 1 to n of ai is equals to 1. So,
1.
So this is equals to what? 1. So
1.
what is the expectation of x bar here? Mu.
Mu.
Okay. And if I'll substitute this value here, so it will be equals to mu minus mu.
That is 0.
0. Then
Unbiased.
it is what?
Unbiased.
So my first statement is correct or not?
Yes, sir. It is correct.
Correct. Okay. The second option is expectation of s square, which is equals to n minus 1 upon n of sigma square. Can we so all the three options, so next three options are regarding what? Expectation of s square. Right? So
yes, sir.
Can you find out expectation of s square similarly?
Okay, sir. I will do.
You will do, right?
Yeah.
So the same procedure you have to follow. So here what you have to do is xi minus mu to the whole square. So x1 minus mu to the whole square plus x2 minus mu to the whole square, like that, and you have to do some calculations, right?
Okay, sir.
And once you find expectation of x square, then you know how to find the bias for that.
Yes, sir.
Yeah, then you can do it.
Okay.
Sir, please could you first read a recap of week 5, sir?
Okay, week 5. Yeah. Okay, I need to see first of all which are the topics are there, because I haven't prepared the slides for that today. So,
Sir,
okay,
in week
okay,
7, sir, in week 7, like you haven't covered that Chernoff bound and.
No, not required actually. That's what I told you at the. I don't know when you joined, but I told you at the initial part of the session that what we are going to discuss is which is important for your quiz point of view. That will be better, no?
Okay, sir.
Yeah. So week 5, we have joint distributions of discrete and continuous. So one random variable will be discrete and another will be continuous. Then the joint distribution for continuous. So both the random variables are continuous, and then marginal densities and independence. Okay. So you guys can help me out to. Okay, we'll see. So first is joint
distribution.
Joint distribution of
discrete continuous.
One discrete and continuous.
Actually, it's multiple for, but yeah. So we'll check for 1, 2. Means like one discrete and continuous. Okay. Okay. So here, suppose x is my discrete random variable. Okay. And y is my continuous random variable. So how can I write the conditional density for these distributions? So can I take one example from the sir's slides? Will that be okay?
Yes, sir.
Yes, sir.
So I think because
definition,
yeah.
Then the example.
So definition, then I can write it, but again it is only formula, right? Maybe I'll write it. So first of all, here fyx is of y, it is called as the conditional density. So this is the notation for that conditional density. So it is like usual conditional density, right?
Yeah.
So it is y given x. The probability that y given x. This is conditional. Marginal density of y, I can write it as like summation of x belongs to some tx. So what is tx here? Range. Right?
Range of x.
Range of x into fx of x. So this is what? PMF. Correct, no? Into. So this formula, does it look familiar? So what I have written here, does it look familiar? No. Okay, tell me.
It's what we do.
Yeah, tell me what is this? How can I write fy given x of x? Fy given x of y. How am I writing this?
F x given y.
F
X given y.
of x
F of y of y.
F of
divided by
Fy of y.
right. So if I wanted what?
No, like here I have a question. Like it needs to be multiplication of Fy of y by Fx of x.
And the denominator we should have Fx
Denominator should be Fx of x.
Sorry,
and-
yeah. So this is sorry, yeah. This should be Fx of x, no?
And multiplication of
Y.
Yeah.
Yeah, numerator. You have
Numerator.
We have to multiply
Multiply
Fy.
with Fy of y.
Fy, yeah. So, yeah. This should be like this, right?
Yeah.
So still we are
No, sir. It is
no. This is 1 minute. I missed.
y given x of y.
Joined by the marginal.
Yeah. Okay. This thing is
Can be represented like this also, and yeah, that another thing also. Joint of.
Yeah, I have to write it like this, no?
Yeah, we can represent like that also.
Yes,
F of
sir.
x,
Yes,
y,
like
x, comma,
this.
y by.
Y divided
Into
by
F of y.
again we can write fx given of y is equals to like this divided by fy of y. These two formulas are right?
This two formula is fine.
Yeah, so for this formula and this formula I can write it like this, no? Multiplication of this. Okay.
Based on these two equations only, we told the previous
we told,
equation.
no? Yeah. So okay, I'm not going into that. But it is just a conditional density formula only we are applying here.
Yeah, and the
Here,
joint density is not given, then we will write the other one. That's where, yeah.
So by using this formula only, this is derived. So this is the marginal density formula. So what I'll do is I will take one more example here, given in the problem. Sorry, in the lectures. So that is like good for understanding. No? So suppose my x is uniform in, okay, I'm taking some different example, okay, 0, 1. So x is uniform in 0, 1 and y given x is equal to 0 is, let's say, some normal distribution with the mean what?
0, 16.
No, take anything. It's like 5, 4. Y given x equals to 1 is, it can be anything, okay? Since my x is discrete and my y is continuous, I know x is discrete and y is continuous. So given that my discrete distribution, what is the distribution of y? It may vary according to the problems, but it can be, suppose it can be y given x equals to 0 is can be exponential also, right? So can I write it like this? Okay, that is also fine. No? Suppose I wanted to say that this distribution is according to exponential 3. So my lambda is 3. And my y given x equals to 1 is, suppose it is 0, 1.
Here y given x is equal to 0 is itself a random variable.
Yeah, so it will be random variable, no?
Yeah.
So you can see this distribution from the distribution you can see, right? So y given x equals to 0 is having a distribution of exponential, and y given x equals to 1 is having a distribution of normal 0, 1. So if I wanted to find what is the distribution of y, how can I find?
Like
Okay, first of all tell me how can I write this? Fy
y of y
x equals to 0 of y. So this is exponential 3. So first of all I will write the
summation of the probability into
why summation?
3 to the power minus
this is exponential 3. Yeah, so yeah, somebody was saying, somebody was saying
3 e to the power minus 3y.
E to the power
minus 3y.
Correct, no? Because for my exponential distribution, what is the distribution? Lambda e to the power minus lambda x. For this is fx of x, right? So here this is exponential 3. So this is the PDF for exponential distribution, right? So I'm just replacing this lambda because here lambda is equals to 3. I can write it as 3 into e to the power minus 3y.
Yes, sir.
Okay. Okay. Tell me this. Fy given x equals to 1, which is normal 0, 1.
1 upon 2 pi.
So 1 upon root 2 pi.
Yeah.
Root 2 pi.
1 upon root 2 pi.
Root 2 pi.
Sigma.
E to the power
E to
minus
power
y square by 2.
No. Into 6.
Yeah. Under denominator.
Minus pi.
Y square, no?
Yeah.
Minus y square upon 2.
Okay, why it is
upon
like
2.
that? Y square upon 2. Why it is like that?
It is x minus mu.
Because this is 0, 0, 1. This is mu equals to 0 and sigma square equals to 1.
1.
Where, because here the equation should be 1 upon root 2 pi sigma. So sigma is 1. So I haven't written here 1.
Right, sir, right.
To the power minus y minus mu. So mu is 0 here. So I can write minus y square by 2. So
Yes,
these are two my distributions here, right?
Yes.
Now I wanted to find this marginal density for y.
Y.
How can I write?
So probability of 1 by 2 into 3 e to power minus 3y plus.
According to the given formula, right?
Yeah.
So what was the formula? It was a PMF. It is a multiplication of PMF into that. Right? The summation of multiplication of PMF into the
PDF.
Right. So for y given x equals to 0, my distribution is exponential. So I can write. And what is the probability for x equals to 0?
1 by
1 by 2.
1 by 2.
Maybe I can write it like this, right? Fx of 0 into fy given x equals to 0.
Yes.
Of y plus fx of 1 into fy
given x equals to 1
of y. That should be my marginal density. So what is fx of 0? So since my x is uniform in 0, 1, it should be equals to 1 by 2 into this distribution is this, right? This one.
Yes, sir.
So I can write 3 into e to the power minus 3y plus fx of 1 is what?
Half.
1 by 2.
1 by 2
Into 1 by root 2 pi.
1 by root 2 pi
minus y square by 2.
Yeah.
This is how you can find the marginal densities here.
Right.
Law of total probability.
Yes, you can see. Yes, this is actually law of total probability. Yeah. Okay. So generally the question, if will come from this part, right? It will be like that only. So you can't solve it further. Maybe you can solve for some. See, you can find a value like this. 3 by 2 is 1.5. 1.5 into e to the power minus 3y plus 1 by 2 into whatever the constant will be there. And somebody asks for fy of, let's say, 5. So what you will do there? You can just put 5
substitute
there.
y.
Yeah, that is the variation there, right? So next
First,
one is
first we should derive the formula for that. Then we put the value.
Yes. So second one is what? Joint distribution for or joint continuous random variable, right? So multiple. I can take joint. So both the variables are what? Continuous. So in that case, what you can do? Okay, there is one more thing is, so if you are given the region, and you said that if it is uniform in that region, then what will be my PMF there for the joint distribution? Suppose my x and y, okay, I will take some example here. So my x and y are uniform in some region D. If it is given as like this, and what is my D? Suppose my D is written like this.
Interval.
Or union 2, 4. Okay, first of all, tell me how to find this region.
प्लॉट करेंगे सर.
हाँ, so how to plot this region?
0 to 2 and 1 to 2.
So first of all, x and y, because you have to find the support, no, first.
Yeah, first support
Yes,
is
sir.
required.
So first of all, now you have to plot this. How can you plot this region? So
0 to 2.
x is varying from 0 to 2, correct?
And y is 1 to 2.
And y is varying from
1 to 2.
1 to 2. So this will be from here.
Yeah.
This box will be there, right?
Yeah.
Okay. And union with what? This
2 to 4 and 2 to
so
3.
suppose this 2 to 4 and
2 to 3.
2 to 3. So this will be like this. Okay. So this is what? So this is my region.
This is the area of concern.
So if I wanted to find the joint density for this, joint density is denoted by fxy of xy, right?
So here area of concern will be from 0 to 4 and 0 to 3.
No, this is not area of concern actually. This is the area of my region, right?
Area of region.
Area of concern will be if I wanted to find something, I'll tell you.
Okay.
So first of all, this is my area, total area, and from this area I wanted to find the joint density. So how can I write the joint density for this? Since my x and y are uniform in D, uniform in this region. So what is the formula for that? So
1 by area, right?
So 1 by
1
area.
by D.
1 by so that not D, it's area of D, right? Area of that region. So it is denoted by this magnet. What is? What?
Yes.
Okay, 1 upon that
Mod.
Yeah, sorry, mod of D. Okay, so 1 upon mod D, right?
1 by
within this region, within D, and for it will be 0 otherwise, right?
Yeah.
So what is the area of this region? So these are all the rectangles, no?
Add the area of both the rectangles.
2 into 1, 2.
So what will be?
1 by 4.
If I wanted to find area, it will be this length is 2.
2 and 2.
1 is 2 into 1 is
4. 1 by 4.
Joint density will be 1 by 4 for given region D, right? I'm not right. I'm just writing D means what? This thing, and 0 otherwise. Okay. If I wanted to find the probability that my x is between suppose my x is between what 1 to 2. Okay. If I wanted to find this probability, how can I find it? Tell me.
Integrate 1 by 4 from 1 to 2.
So yeah, so integrate or else what is any other way?
Using the area also you can find.
We take the area between 1 and 2 and divided by the whole area.
Yeah.
Whole area.
Here since it is uniform, we can just like just find out by using this area method, right? So interested area, so interested region divided by the area of the whole region. So this is my x is varying from where to where? 1 to 2. So this is my region of interest. Correct? This orange shade is my area of interest. So what will be my probability here then? So tell me what is this area? This orange.
It's a unit square.
It's 1.
1, right?
1.
And what is the total area?
4.
So is this correct?
No, we have to consider the total f of xy, right?
What do you have to consider?
0.25 into 1 by 4, right?
No, why? We did not do, no, this is it, right? So if I'm finding the probability, I need not to multiply again. So see this joint. So there are two ways, right? So one way I can find by this method, area method, or I can use this integration. So then what I have to do use this joint density. So by using integration method, how can I find it? I wanted to find the probability between x equals to 1 to 2 and y equals to from where to where. So okay, suppose I wanted to find between 1 to 3 fxy of xy dx, right? Not okay, 1 to 2, no, sorry. This is what my probability. I'm finding out this. So it is 1 to 2. What is fxy of xy?
1 to
1 by 4. Right?
Yeah, yeah.
So 1 by 4 is constant. So
we have to integrate 1 by 4, varying x 1 to 2 and y 1 to 2.
Okay, okay.
Correct. So this answer and this answer is same. So this joint density will be this. So you can use for using the integration, or you can use for this also. You can find the area by probability by using this area method also. In case of this uniform thing.
Only in case of uniform, this will happen, right? Right.
Understood, right?
Yes.
Yes.
And Mayur, the z-axis for this particular graph is the probability, right? Which determines the height. The graph that you have just made on this x is one variable, y is another variable, right? And z would be the probability.
Yeah, correct. But yeah, don't take into this consideration now. Okay.
So where I'm coming from is,
because this
where I'm coming from is in the lectures that explanation has been given.
Correct.
But with the
so in 3D,
but with figures then, but figures other than rectangle and cube, it is so difficult to interpret. मतलब समझ में ही नहीं आ रहे वो क्या shape बनती है या क्या distribution होता है और क्या density आती है.
So since these are the what support, right? Support for that x and y. So we are just drawing the support, right? And if you now in this case, what will happen? Like, all the z-axis also, if you are trying to draw in 3D, what will get? Every probability will be 1 by 4 since it's uniform, right? So it will become like this. So if I wanted to, I don't want to draw, but yeah. So if you see, you understood, right? It will be the
it will be 1 by 4 height.
1 by 4 boxes.
Yeah. 1 by 4 box, height of 1 by 4, right? That is what you mean.
Height of 1 by 4. So in 3D, 2 boxes you will get, no?
Yes. 2 boxes, each of 1 by 4 height.
4 height. And with this support. Correct?
Yes, right.
So what I said is, if you know the joint density for any variable.
Can you mute everyone? It's disturbance a bit.
Maybe it's my fan actually. Okay. When did I just,
Excuse me.
It's fine now. It's fine now.
Excuse me, sir.
Hello, sir. Sir, can you please explain that joint distribution integration part one more time?
Can anyone tell where is the solution of that live session that end user took on 7th March?
Andrew sir, do not give the solutions.
Okay. We have to watch the live session.
Yeah, live session you have to go there. Last time also he denied to share the detailed solution.
Okay.
Okay, and then you have to go to the live session. I was also asking you. Okay.
Okay, thank you.
Hello. Yeah.
It will be better if somebody has them shared on the discourse.
Okay. So there is no disturbance now, right? Hello.
Yes, sir.
Okay, fine, sir.
Fine, sir.
So we saw.
So can I ask my question at the end of this live session? I have doubts from quiz 2. Sorry, mock of quiz 2.
Mock, the questions will be taken tomorrow.
Okay. Okay, sir.
One more doubt. I just want a theoretical answer. Where do we apply this double integral? It's a little confusing. When do we use the double integral? What are the situations for this continuous random variable?
Double integration you can use for finding the probabilities, right? So if you have
but sometimes we do by area itself, and that's little confusing.
area when you'll do when this it is
when you give
uniform
the
in that
region
So
uniform.
if it is not uniform in some region, suppose, then
Okay.
what we'll do? Suppose okay, I will take one example here. Suppose my x is exponential. Okay, x is exponential lambda for some region you take for x is greater than 0, right? And x and y is also exponential. Okay, exponential. Okay, I can say it's lambda 1 and here it's lambda 2.
Hello, sir. Network issue. It's
Okay. Hello, am I audible?
Yes.
Yes, sir.
Yeah.
I got locked out, so 1 minute I'll
Yes.
ask for the. So suppose you have given the joint density, right? So in that case, and if you wanted to find some probability,
Your screen is not visible.
yeah, I know. So since I got locked out, so
Okay.
the host control is also gone. So I'm asking them. So in between, I'm telling you that when you are given the joint density, and if you wanted to find some probability by using this joint probability over x and y, some x and some y.
Your screen is not visible.
Yeah.
Okay.
Yeah.
Yeah, screen is required.
No, okay, just a minute. Okay, just a minute. I asked him to make me co-host again. So after that,
Okay, sir. Let us discuss.
just wait.
hello, sir.
Yes.
Meanwhile, can we discuss practice assignment question number 1?
Practice assignment or what? Then, but I am not able
Week
to.
8. It's okay, sir. It's okay.
Okay, so
But
you want to discuss it only?
yes, sir.
Week 8, question number 1, you're saying?
Yes, sir. Practice assignment 8.
Okay, so the question is let x1, x2 to xn be n IID samples from a random variable x with mean mu and variance sigma square, right? Let x bar square will be an estimator of mu square, where x bar is a sample mean. Is an unbiased estimator of mu. Is the estimator x bar x mu bar is unbiased always. Okay. Okay. So x bar square is the estimator for mu square, right?
So what does it mean? Mu square, you mean that it is the mean of the, it is a second moment, right? Mu square
is the second moment, yes. So it is the estimator for the second moment. So given that it is a estimator for second moment, and it is said that x bar, which is sample mean. So the first moment is unbiased estimator of mu. It is given that the first moment is unbiased estimator of mu. Then tell me if that x bar square, the second moment, is also an unbiased moment of mu square or not. That is a question. You understand? So given that x bar is an unbiased moment estimator of mu, but it is very you can easily prove, right? So x bar is an unbiased estimator of mu, it is given. That means x bar is equals to mu, right?
Okay.
Correct, no?
Yes, sir, it is correct.
Then only you will get that bias equals to 0 in that case. So that means expectation of x bar, so expectation of a sample mean is equals to mu. It is,
Yes,
you get to know that. Now, I wanted to find the expectation of x bar square now, correct? And I'm going to, so what will be the bias for x bar square? How can I write bias for x bar square?
Expectations of x bar square minus expectations of that distribution.
Or yeah,
mu square minus mu.
Which you can say mu square, right? Expectation of x bar square minus mu square. You can write it like that.
So why it is mu square?
Because we are finding it for the mu, no? So sorry, we are finding for, sorry, I'm not sorry. We are finding for mu square, right? That's why we are, because you are finding the error for mu square. That's why we are taking that thing. Okay, you're not understanding.
One thing over here, is the mu square the whole square of that or individual?
Individual mu square, no. Mu square is what? What is mu square? It is a square of distribution mean, right? It is square of distribution mean. It is that simple. Still not understanding?
It's supposed to be coming to mu square itself, so it should be unbiased.
No. You have to check, no. See what is given there in the question. So in the question it is given that my x bar, so my x bar is unbiased estimator of mu. Suppose for the given distribution x1, x2 to xn, we have an estimator for mu as x square, x bar. You're understanding? Okay, you're understanding my sentence or not?
Yes, sir. Yes.
So for the given distribution, my estimator is x bar for the parameter mu. Now it is given that it is unbiased estimator of mu, so that x bar is an unbiased estimator of mu. That is given to me. From that, what I can say is, because what is the formula for bias? Bias of x bar comma mu, right? I can write it like that, right? Because it is theta hat comma theta. So I can write bias of x bar comma mu equals to expectation of x bar minus mu. And it is given that bias is equals to 0. So I can say that expectation of x bar is equals to mu. So I got this this equation, right? Expectation of x bar is equals to mu from the given sentence. Now what I have to find? I have to find for mu square. So consider mu square as another parameter. And for that mu square, which estimator is given? X bar square. X bar square is the estimator given. So what will be the bias for x bar square comma mu square?
Expectations of x bar square minus mu square.
Now it's
Sir,
fine.
if screen can be shared, it will be helpful.
Yeah, but still I am not a co-host, I guess so.
Yeah.
Sir, now that x bar square becomes what? Expectation of all summation of all the x square. Now they are IIDs. They are IIDs.
Okay, expectation of x bar squares, no? So expectation of x bar square means expectation of x1 square No, x1 square plus x2 square plus x3 square plus
Yes, sir.
divided by n.
Now each one of them are IIDs, so we can actually multiply mu into mu.
So you okay? No, you are thinking in that way, huh? But
Sir,
but
actually
no.
it
First of
yeah.
all, we can find out expectation of x bar square by using the formula variance of x bar square. Okay. In that way also. Okay, let's see. So what is x bar square? What is x bar square?
X bar square is x1 square plus x2 square. It is like that, na sir? x1 square plus x2 square. Dot plus xn square divided by n.
So if I wanted to find out expectation of this term, so what it will be? Okay, all are the IIDs. Okay, that is okay. So then what will be the expectation
Mu,
of? So it will be
n mu square divided by n. That is mu square.
Yes, sir. So finally, this is becoming zero, coming to zero. So shouldn't it be unbiased?
So it would be unbiased, na sir? Always, I mean.
Okay, it should be, I think, but I am also thinking that it should be unbiased. Maybe I'll check once. Okay, if I'll check today and I'll ask. One minute, just a minute.
Sir, this x bar is particularly the second moment. Is there any notation for this? I did not know actually. I was thinking maybe it could be the sample square.
Sample square. Okay, just a minute. I'll ask one minute.
X bar in the most of the cases is equivalent to the mu, sir, no? For the main distribution.
X bar is the mu, so we can perceive it both the ways. If there is any donation.
If x bar is unbiased, sir, then we can take mu square is equal to x bar square.
In that way, also we can prove that if we if mu is equal to x bar, the expectation of x is somewhere x bar. So
okay. No, just a minute. This x bar square is what?
Mu square, because x bar is mu.
Just a minute. Just a minute.
Okay, okay, fine.
So yeah, so this x bar square is square of this terms.
Yes, sir. That's what I was saying.
So
then it will not be. Then it will not be.
Okay, no? Now?
Yes, got it.
Okay, so somebody asked me this question, no? When double integration will
be used. I just want the theoretical. I don't want you to explain some problem. Just want to know when we apply. So when it is not uniform, so then we go for
with uniform also you can use after finding out the joint density, you can use the double integration. But
that will be easier.
Easier to find from the area.
Yeah. Yes. So when there is
Yeah. So when there is no uniform distribution, and if you wanted to find, so you know that procedure, no?
Yeah.
You can use those formulas. Yeah. Then it's yeah. But in that case, what you have to do is you have to find the support properly.
Yeah.
Support you have to.
That is a challenge.
That is the important thing. The other things are not that difficult. The first important part is to find the support.
And so one more doubt also. In the lecture, sir has checked for a valid density or not. So should we do in the exam also to check whether the density is valid before going?
Generally not required, because if you are giving any distribution, it should be a valid.
So in the exam, you don't have to do that.
No, not required. Unless and until we asked you to find, we asked you to say that like you have to find what is it a valid PMF or not. You need not to find.
Okay.
Because since if you don't give you the valid PMF, then you are not able to find any answer, right?
Yeah.
So you have explained very much, very well in 5.4 lecture in the previous session. It was very fine. It clarified us.
So that will be it. Okay. Generally, in week 5, the important part is to find the support. So if you're able to find the support, then you can apply these formulas, integration formula for marginal densities. You know, if you wanted to find marginal density for y, then what you have to do is you have to integrate over x, right? And if you wanted to find marginal density for x, you have to integrate over y. And if you have given some joint density, okay, and integrate over x and integrate over y, what of joint density, right? But the most important part in week 5 is to find support. If you are able to find support, then it's easy to calculate the next things, right? And one more thing is, if it is given the some valid PMF or valid PDF, if you wanted to find some value of constant, then how can you find? You have to just equate this joint density. So integration over this support of x and support of y equals to 1. Right? No?
Yeah.
Okay. So yeah. So that is from week 5. Nothing much from week 5 is there. So I think I have covered a lot of concepts, I think, and these are the most important concepts there, right?
Sir, can you take a question about CLT?
Okay. CLT, maybe can you ask tomorrow, or maybe, okay, I can take one or two.
Only one question.
Yeah.
So let's
I will
take one from CLT.
Okay. Can you suggest me any question from week 7?
In mock only is there, sir?
Mock questions, all the questions will be explained tomorrow. Apart from that, tell me anyone. So that, okay, maybe can I take it from activity questions? CLT.
Yes, sir.
Okay, tell me. 7 activity is fine. Activity questions or no?
Yes, sir. Something from activity 7.6 should be fine.
Because mock questions anyway you will be discussing tomorrow, so it's better that we can discuss some other questions, right?
Sir, tomorrow's session is completely on mock, or we are going to discuss anything else?
You can discuss any doubts regarding any questions from this week's.
Okay, sir.
Mostly the questions. So whatever theoretical part was there, I have explained, right? And anyway,
Yes.
we had a session on Monday of Andrew sir. I think he has also covered a lot of questions from different concepts. So whatever doubts are remained, like whatever remaining doubts are there apart from mock, also you can ask there.
Okay, sir.
So it's CLT question. Which one you want? Theoretical one, na? Or
theoretical, it will be better.
Moment generating simple one. Okay. Can you you guys just tell me, okay? So number of accidents in a certain city is modeled by a Poisson random variable with an average rate of 9 accidents per day. So here, what is our random variable x is? What is the distribution of x? It is Poisson. Lambda equals to 9. Right.
Yes.
Suppose that, right. So suppose that a number of accidents on different days are independent. So my first, so x1, x2, x3 are my days, right? So this random variable. So x1 is the random variable which x1 is a random variable which represents number of accidents on first day, according to Poisson 9. X2 is my number of accidents on second day according to Poisson 9, like that. And all these x1, x2 to xn are independent. It is given that. So and identical also. So these are IID random variables according to the distribution Poisson 9. Okay, this is information is given to us. The next is use the central limit theorem to find the probability that there will be more than 3,300 accidents in a certain year. Okay. So we have to find the probability for number of accidents more than 3,300 in a year. Assume that there are 365 days in a year. So now tell me how many n are here? How many n we are considering? 365. And what we are saying is we have to find the probability for more than 3,300 accidents. So what we are going to do here over here? So we are going to get the sum, right? So it is x1 plus x2. So number of accidents on first day, number of accidents on second day, plus number of accidents on third day, until number of accidents on 365th day. It should be greater than how many? 3300. You understood this statement?
Yes, sir.
Yeah, sir.
Okay, this statement is clear, right? So I can write in this fashion. So my x1 to x365 is IID Poisson with lambda equals to 9. What I have to find is probability that x1 plus x2 until x35 plus, right, 365, it should be greater than 3300. This is the probability I have to find. Consider this as y, this sum as y. So what? So what I have to find is y is greater than 3300 by using what? Central limit theorem. Okay. Okay. Now what I have to do is first of all tell me what is the mu here. What is the distribution mu here?
9.
9. Lambda, which is 9, right? For Poisson random variable, the distribution mean is same as that of the rate. So it's 9. And what is sigma square here?
9.
9.
Because in case of Poisson, mean and variance are same. So what is sigma then? It's 3.
3.
And n is what? 365. Okay.
365.
So what is our procedure to find by using the central limit theorem? First of all, we have to convert it into that approximate normal 0-1 distribution, right? So this is the sum for the Poisson random variable. What I can do is I will just subtract mean. So what will be my mean for 365 random variables? It will be n into this mean, right? Distribution mean. Because since you see x1 is having mean mu, x2 is having mean mu, like that. So my okay, what I have basically what I am going to do is this one, I'll write it down. So if I don't remember the formula or something, how can I do? I'll tell you. So my y is what? X1 plus x2 plus xn, or x365 in this case. Okay. Now what is the expectation of y?
X1 plus x2
So it is
till
expectation of x1 plus like this, right?
Yeah, sir.
So what is expectation of x1?
Mu.
9.
Mu. So mu or okay.
N mu.
In this case, what I'm saying
It-
is
it-
to the power 3.
N mu, which is
n mu.
N
So,
mu, yes, sir, N mu.
yeah, 365 into n.
So that is why that n mu is coming in the numerator, right?
Formula.
So you should not mug up that formula as it is. You can just by seeing whatever distribution is given, you can easily find it out, right? So first of all, you have to know you need to know what we are going to find it out. So here, what we are going to finding out, the number of accidents in a year. That means it is a sum of accidents over all the days.
It's 9, right? 365 into 9.
Yeah, sir.
Sorry.
Mu is 9.
Okay. Yeah. Okay. So 365 into 9. Yeah. Divided by. Now the another step what we are going to do is we are dividing it by what?
Root n sigma.
Sigma.
Okay. Root n is what here?
Root
Sigma.
365
into
3.
Into 3.
Which should be greater than 3300
minus 365 into 9
into 3. So right. So
yes.
your value is there. You can just say that f of this, right? So f of this value.
fz of.
So actually, okay, fz of this. So it will be actually 1 minus fz of
0.26.
So this will be 1 minus how much?
Fz of 0.26.
Fz of 0.26. So that should be your answer. Okay, you got it right. Why I wrote 1 minus fz? Because here it is greater than.
When we need greater than, we use -1, right?
1 minus, yes, 1 minus. And when we wanted less than, then it will be only fz. Because if you see the normal distribution curve, that is a bell-shaped curve, right? It's 0 here. So this is the PDF curve, right? So at z equals to something, so greater than z means what? This portion, no? If my z is here, suppose, so what z is greater, some greater value of this will be this portion, right? The black one. So entire portion is what? 1. Correct?
Yeah,
no?
but this is
I'm saying about
PDF, right?
PDF. Yeah.
Yeah,
But in case
yeah.
of CDF, it will be like this.
Yeah, yeah.
There, no? So 1 minus. Generally, we will do like this. But for representation purpose and to understand better, we can understand from bell-shaped curve. No. So
Yes, yes.
we are interested in this portion. So by using the CDF, because the area under total this curve. So area under this curve is 1. So 1 minus whatever this area, the probability for this area, we are just going to cancel. And when my z is less than something, so this area, no, this is less than. So in that case, it will be fz only, right? As a CDF, and greater than this portion. So this is greater than. So in that case, what you have to do is for finding out greater than, you have to subtract that fz value from 1, and for less than, you need not to subtract anything. It should be only fz. Okay. Got it?
Graded the question number 8, week 7.
Okay. So let x be a random variable having the gamma distribution with parameters alpha equals to 2n and beta equals to 1. Okay. Use the weak law of large number to find the value of n such that probability that mod of x by 2n minus 1 is greater than 0.01 is less than or equal to 0.01.
Okay. So here I was not understanding what is x. Is it the summation of all those? Like nothing is mentioned over here.
Okay. But do we need the summation here? Okay, x upon 2n minus 1. Then
X is gamma. It's mentioned in the hint.
Hmm?
It's mentioned in the hint above.
What's mentioned in the hint is a general property that sum of n independent gamma is this. But
correct.
x is what?
Gamma, if x is gamma.
But in weak law of large numbers, if you wanted to find n, but is it required there?
Yeah, it's x is random variable that is given, right? What else information we need?
So we don't need anything, no?
Sir, x not x bar. That is x.
Okay. Okay. So here delta is 0.01. This probability is this. So we are just going to. Okay, if you don't sigma square.
So shouldn't it be like 2n into 0.01?
Where you are saying 2n into 0.01?
Because if we try to convert this into the normal, sir, if we try to convert this function that x divided by 2n minus 1, if I want to get it to normal 0, 1, then this becomes x minus 2n divided by 2n.
But for weak loss large number, why you need to convert it into this normal?
That is also mu x bar minus mu.
X bar minus mu.
X bar minus mu is greater than delta.
Yeah.
That is also explained like that. So we somehow have to bring it to that. So we can write this as x minus 2n divided by 2n. So if we want to move this 2n, we can actually bring it to the other side where delta is 0.01 into 2n. So this is how we can convert this into x minus mu, because mu is 2n for this case, for x. The alpha by beta is alpha by beta is 2n by 1, so it's 2n. So we have the mu as 2n. So this got converted into x minus 2n. But how is this 2n playing a role? Because I'm getting a different answer. They have taken to we should.
No, but that is fine only, right? X minus.
So, but according to me, when this 2n goes on that side of the inequality, 2n into 0.01, so this becomes the delta now. This is the delta now.
Yes.
So we have to take the square of the delta. But in the solution, they have not considered 2n as the square, but just normally 2n, and then delta was the square, which is 0.01.
We'll check the solution. Where it is solution?
Sirs, in supplementary content.
But whatever you did, I think that is also correct only.
So I am actually approaching these questions in a different way, so it might not just coincide with what's given over there.
Week 7, no?
Week 7, yes, sir.
Question number 7.
8. Yes, sir.
Okay, but here x is taken as sum of.
But sir, why is it's not mentioned anywhere that x is sum? It's just a random variable that we know. We have to be given that it's x bar or it's the sum of those. That's how we convert.
See, I think it is because, see, let x be a random variable having the gamma distribution with parameters alpha equals to 2n, right, and beta equals to 1. So if the sum of n independent gamma alpha beta is what? N alpha beta, no?
That's a property.
So consider this gamma equals to 2n into 2n comma 1.
Okay.
So what it will be then? So
if we take, then it will get converted into 2 comma 1.
So suppose this is gamma 2n comma 1, right? This is 2n comma 1, so because this is alpha beta.
Yes, sir. Yes, sir.
Right, and so I can safely say that it is the sum of independent what?
N gamma, so it will become 2 comma 1.
Gammas, yes, 2
N gamma, so it will be 2 comma 1.
Yes, sum of
so
n.
This is one of the approach, I understand.
Or you can
but
say 2n of 1 comma 1.
Yeah, we can say that also.
Yeah. So
both the thing are same. But sir, how I am approaching, where am I going wrong in that?
No, but still your answer is going. That should
No,
be.
sir, it's not. No, sir, it's not coming. Like according to me, the 2n should be squared. But if I square the 2n, then I'll obviously get a different answer. Because I'm not treating it as a sum. I'm just treating x as an individual, and then.
But x, why you are treating x as okay? Because you are saying that this distribution.
Nothing was. Sir, if the hint was not given, because the hint is just a general property, if the hint was not given, that's not a part of the question. So that's where I'm getting confused.
Okay, so.
Sir.
Maybe, okay.
Sir, n gamma beta is showing this is a sequence of some individual variables. So x is equal to x1, x2, dot n. I think doubt is here.
No, that she also got to know, but now she is saying that what she has taken is x as equals to 2n comma 1 without taking the sum of that.
If
right?
sir, so it's relate to only one variable, na sir, not sum of all variables.
Actually not mentioned in the question, like either the question is incomplete or something.
Okay, okay. Maybe I'll ask. What I'll do is I will ask this question to take in tomorrow's session. Will that be
Okay,
okay?
sir.
Huh?
Okay, sir. No
Your
problem.
same
Thank
question. So you just joined in the beginning. You'll get
you.
the
Okay, sir.
answer. Hmm?
Okay, sir. Thank you, sir.
Yeah. So shall we stop now? So whatever tomorrow mock questions will be discussed and some more questions. Whatever doubts are there. Okay. Remaining doubts.
One question I will ask. Hello.
Tomorrow now.
Once
Huh?
a single different question out of this.
Hmm.
Is the Z table when we see on the net to verify the values given in the questions, it does not match.
No, you have to use those values only which we have provided.
Okay. What is the exact value then? Whether it is provided or on the net given?
No, sometimes what happens is internet, like they will provide, I think, for 4, 5, 6 digits, right?
Yeah.
So what we'll do is sometimes we'll just round it off or something like that. It's not basically, I think, first 2 digits or something. Those are the correct values. No, it's okay. So what you
In
have to do
exam, these values are given, na sir?
Yeah, values are given, so you need not to worry. You have to use only
Okay,
those
sir.
values.
Okay. But we should learn, sir, how to see the Z values on the net.
Net, you need not to learn. You have to learn on the Z tables.
The G tables are there on the net, but it is not matching at all sometimes.
At all?
Okay.
I don't know. It should be matching, right? It should be near, like
in place
suppose
of
it is
1.76, it is coming 1.26.
Oh no, that much of
No, it's matching only in the
No.
later.
Yeah, later you can say, suppose it's 1.99.
I think he's
I'm not talking about that.
Maybe you are making some mistake while.
Okay, that's why you're asking how to exactly see.
Okay. Okay, maybe in the next sessions, like after this exam, right? Because we are providing values in exam. So after this exam, in one of session, we'll show
How
you
to see exactly.
Z tables.
Okay, fine.
Okay.
Thank you.
Bye.
Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.